Coming up on this edition of The Climate Show, we talk about the extremes: flooding, cyclones, snowstorms. We talk to one of the highest profile climate scientists in the world. He's in New Zealand at the moment. His name's Dr. Kevin Trenberth. And we find out, where the heck are we headed? Also, John Cook's along as well. We're going to hide the decline with him. No, we're not hiding. No, he's going to talk. Anyway, we're going to find out what hide the decline is. And a green machine that sucks CO2 out of the air. All that and more is coming up next. This episode of The Climate Show is brought to you by Celsius.co.nz, HotTopic.co.nz, SkepticalScience.com, Scoop.co.nz, and Kiwi FM.
What good is a drop in the ocean? What good is a drop in the ocean?
Hello and welcome along to The Climate Show. It's episode number 8. Nice to have you along. My name is Glenn Williams, broadcasting from the QFM studios in Auckland City. My co-host cannot be possible without him. Of course, it's Gareth Ronalden in North Canterbury and Waipara. Hello to you, Gareth.
Hi, Glenn. How are you?
I'm pretty good. I tell you what, I'm not as shaken as you guys have been in the past week in Canterbury.
No, it's been a very grim a week or so in Canterbury since the earthquake last Tuesday. It's been tough. I mean, I'm glad to say that all of my family have got through this okay, and our friends all seem to be shaken, but with damage to their homes maybe, but basically alive and well and knuckling down to getting on with rebuilding their lives and rebuilding the city. So yeah, it's been a horrible time. We're going to talk later on in the show to Kevin Trenberth, the NZ-born US-based climate scientist, he was actually caught right in the middle of it and wrote a graphic account of the shaking that I posted on Hot Topic last week. So yeah, your parents were caught up in it too, don't I understand?
Yeah, and as you say, I'm so thankful that that my family and my friends have stayed safe throughout this. But yeah, unfortunate that not everyone could be as fortunate as all those people. But I can't really imagine. What was your personal experience in North Canterbury there?
Well, it was a sharp earthquake. I mean, it was bad enough that my wife and I ran outside and the dog was woofing loudly. It actually shook a few more things off shelves than the original September earthquake did. But it didn't last as long, and it didn't seem to move the house as much as the original quake did. Sort of sharper, but not quite so bouncy. This is great tectonic expressions I'm using. But I mean, it was a numbing experience for us all, and I know my wife and I found it really hard to concentrate on anything for a few days after that. And you find, I know that friends of ours in Christchurch find the incessant aftershocks really hard to cope with, because you never know, whether it's going to be another big one or not. And so you end up in a permanent state of stress. And we also get up here, we don't get all the aftershocks, we get a few, but you don't stop being nervous about it. No. You don't stop thinking, whoa, where is this little quiver going to turn into something more? Is it going to be more damaging? Where's my daughter? Where's my son? Those sorts of things make life very, very tough. And I really do feel sorry for the people of Christchurch, who many of them still don't have power or water or sewerage facilities, homes destroyed, wrecked, cast to the four winds. It's going to be a tough time in Canterbury, but hey, it's a new week and life has to go on. And the Climate Show, we need to focus on the big things and keep our eyes on the ball.
Well, that's right. But on a personal note, I do want to say that having spent 10 years in Christchurch and now being an expat, I have an awful lot of sadness about the fact that the central city is in the state it's in, and the apartment that I used to live in probably won't survive this and will be demolished. And then the time I spent in Littleton as well for 6 months, and that town will never be the same again. The Christchurch that I know and love will certainly be completely different into the future, and I guess a whole generation of people who live there will also be defined by this event as well.
Yeah, that's right. It certainly is a life-changing event for all of us, and luckily for some of us, not in the way, not in a life-ending way, but perhaps the population at large isn't quite ready to go there yet, but people are beginning to think about how to rebuild the city, how to move forward. What can we do to make Christchurch a vibrant and modern and forward-looking city?
Well, that's a good point, and I hope that one day in the future, in the solutions section of this show, we might be able to include some things that are being done for a new Christchurch that will mitigate some of the greater problems around the world.
Yeah, well, already a group of former mayors have got together and talked about the sort of city they might like to see created in the future. And they've talked about low-rise development, sustainable building, low carbon, all the rest of it. And if we can take the best of what we know we can do today and build with the view to the future and create a city that, I don't want to go on about this forever, but one of the examples I use is that the town of Napier on the east coast of the North Island was destroyed by an earthquake in the 1930s, and they rebuilt it with the latest modern architecture, and now people flock to Napier because it's the perfect Art Deco town.
Yeah,
and people come from all over the world to see the buildings there, and I'm not suggesting that Christchurch is necessarily going to be able to do that, but maybe there's something in the Napier experience that we can learn from.
Absolutely. Well, if you're wondering what the show is about, it's not about earthquakes in particular. It is about climate change, and we go through some of the news of the time. We also have our feature interview. Great guest this week, who is Kevin Trenberth, Dr. Kevin Trenberth, I should say. He's one of the most well-known and well-respected and highest-profile climate scientists, and he's in Queenstown at the moment at a conference there, and so we're going to catch up with him, I think, in his lunch break.
Yeah, that's great. I'm really pleased that we've got Kevin. He is a good talker. He's not afraid to tell it like it is when we talk about climate change and the impacts of global warming. So, but we've got a fairly busy show. We've got some interesting and perhaps somewhat gloomy news before we talk to Kevin. But I thought we'd start perhaps with something a little bit light and fluffy, and it popped up in my RSS feed this morning. And it's Arnie, the governor of California.
The governator.
The governator, Arnold Schwarzenegger. And he issued a call at a conference, Energy Innovation Summit, to end the false debate over climate science. And the analogy that he drew was that when he was an action film superstar, and he started out as a bodybuilder in the late 1960s, but people were they didn't like to talk about bodybuilding at the time because celebrities would do it but not talk about it. So Arnie reckons that he brought bodybuilding into the mainstream and made it acceptable for people to talk about their abs and their pecs and things. Personally, my abs don't talk to my pecs. But he wants to do the same thing for climate science. So that's an interesting thought.
Yeah, well, I mean, he's presided over some pretty bold moves, though, in California, hasn't he, with his hydrogen highway and some of the moves towards sustainable practices.
Yes, absolutely. And it was interesting. There was a major attempt to derail the California efforts to make themselves low carbon and renewable energy. There was a great deal of oil money spent in trying to derail all that at the elections last year, and it failed. And the people of California, I think, recognized that Arnie was pointing them in the right direction. So I just threw that in because I thought it was a lovely image that the Terminator was going to terminate skepticism on climate change.
Does he have a plan of attack? Does he know how he's going to do it?
I don't know. It maybe involves push-ups. Anyway, after that small amount of fluff, I wanted to move on to this week's great graphic. Can you get that up on the screen, Glenn?
Certainly is.
Yeah. There it is, absolutely. This is I think I've used a number from this source as weeks have gone by. It's from NASA's Earth Observatory, and it was the image of the day there a few days ago, February the 24th. And what it shows is the northern hemisphere of our planet, and it's material generated from satellites, and what they've looked at is how the effects of melting snow and ice have acted to warm the northern hemisphere. So okay, when you've got snow covering the land, what it does is it tends to reflect sunlight. It's called the albedo effect. And so having snow and ice on the ground and on the sea has a cooling effect on the whole of the northern hemisphere. What they've done is they've looked at the change in that over a period of years, over the last 30 years that the satellites have been flying. And so on the left-hand side, the blue picture shows you the cooling effect of snow and ice on the ground. And then the one on the right shows you how that has changed over the last 30 years, 1979 to 2008.
Right.
And so the areas of red there are where reductions in snow and ice cover have acted to warm those areas, and it's quite marked around the Arctic Ocean, parts of the mountainous states in the US, but particularly down there over what are the Himalaya and Tibet. So you can see it's a warming effect. It's quite dramatic, and interestingly, it's much more than the models were predicting. So there's a sign of if you like, it's a positive feedback that the general warming has acted to reduce the snow and ice cover, but the reduction in the snow and ice cover is feeding back into the process and increasing the warming.
And this brings us on to the next bit of news about permafrost, and the thawing of permafrost is likely to accelerate global warming. Yeah,
absolutely. This is something that science has been aware of for some time. There is a very great deal of carbon locked up in the permafrost that's left behind by the land.
Well, yeah. Can you explain exactly what permafrost is?
Okay. Well, permafrost is basically frozen ground. The soil contains moisture. Its temperature is below freezing, so it's ice, and it's a mixture of ice and soil. And an awful lot of this was created during the last ice age, and mixed up in all of that soil and ice are roots and vegetation, and what was the ecosystem before the last ice age is down there under the soil. Now, as long as it stays cold, it's like a refrigerator. This stuff is effectively deep frozen in the ground. But as the permafrost melts, so the ice melts, the vegetation becomes exposed to the atmosphere and to bacteria and bugs that can get in there and start to decompose. So it becomes a food source for this microbial ecosystem, and this gives off the greenhouse gas methane. So the carbon that's locked up in these old frozen soils, as they melt, can get into the atmosphere. And there is a lot of it there. Now, this latest study calculates that up to 2/3 of the permafrost in the Earth around the planet, most of which is in the northern hemisphere, in kind of northern Canada and Russia and Siberia, up to 2/3 could disappear over the next 200 years, and that most of this will actually happen over the next 100 years. And the amount of carbon that will release is equivalent to half of the amount of carbon that we have managed to put into the atmosphere since the start of the Industrial Revolution. So if you think that we've put, at the moment, at the time of the, before we started fiddling with the atmosphere, there was about 280 parts per million of CO2. We're now at 390. So you're talking about 110 parts per million. So what they're saying is effectively there's the equivalent of another 55 or so parts per million of CO2 that will come out if this permafrost continues to melt.
So the pessimist in me says that's game over, right?
Yeah, well, you've got to hope not. At the very least, it makes the job that we have to do in reducing emissions much, much harder, because we've got to try and stabilize the atmosphere either at current levels, something above current levels, or something below current levels. So effectively, the stuff that comes out of the permafrost makes it harder because we've got to take that into account as well. So if, let's say we were going to aim, as Jim Hansen wants us to do, for a target of 350 parts per million, that means, first of all, that we have to stop emitting carbon and we have to start sucking it out of the atmosphere. But if the permafrost is melting and feeding back into the process, we've got to then suck all that out of the air as well.
Yeah.
So the job becomes hugely more difficult. It's the biggest positive carbon cycle feedback, to use the jargon, that we know about. And this paper really puts some quite scary numbers on the scale of the problem that we face. And what it does, if nothing else, is kind of double underline the importance of acting quickly, because the sooner we can stabilize temperatures up north and hopefully begin to get them to fall, then the smaller the impact of the melting permafrost will be. Taken together with the earlier pretty pictures of the effect of the reduction in snow and ice in the northern hemisphere, I have to say it's not a pretty picture, and it doesn't actually help when the next item that we're going to look at, which is a new paper by Kevin Anderson and Alison Bowes, which was published last week. They are basically saying that we have to start cutting our carbon emissions really, really soon, because where we're aiming at the moment virtually guarantees much more than the 2 degrees Celsius that the world is aiming for.
And so what they're saying is that where we're aiming at the moment is what is guiding climate change policy around the world. Are they talking about the IPCC projections?
What they're doing this, they're saying, well, look, what happens when you look at where we actually are with our emissions, and they build into their modeling that we're running ahead of IPCC scenarios. So we're looking at a situation where the growth in emissions is faster. And then they look at what sort of emissions profiles we might have to achieve if we really wanted a serious chance of staying under or not going far over 2 degrees Celsius. And they find that the kinds of emissions cuts that are required are up to 10% per annum, which most people who have looked at this consider to be virtually economically impossible, or at the very least only feasible if the planet decides that it will do nothing else economically other than try and get carbon out of the atmosphere. There's a very telling line in the paper which I'll quote. It's from the discussion at the end of the paper, which incidentally is free access, so anybody can download this. It's possibly not bedtime reading, but it's pretty clear as these things go.
It's from the Royal Society, is that right?
Yeah, it's the Royal Society in UK are publishing this.
Okay.
Basically, this sentence struck me really rather forcefully. They said, put bluntly, while the rhetoric of policy is to reduce emissions in line with avoiding dangerous climate change, most policy advice is to accept a high probability of extremely dangerous climate change rather than propose radical and immediate emissions reductions. Yes, so that's why they call their paper Beyond Dangerous Climate Change, because they also, we've talked in the past about this so-called 2-degree guardrail, the target of trying to stay under 2 degrees Celsius, because it has been felt that that was the rough sort of borderline between stuff that we could cope with and stuff that we couldn't cope with.
Yeah.
What Anderson and Bowes also point out is that 2 degrees Celsius does not guarantee a lack of dangerous climate change. It becomes the borderline between dangerous climate change and extremely dangerous climate change. So they're saying that where we're aiming, we're being ineffectual in terms of our policy at aiming for that target anyway, so we're likely to exceed it. We may end up with 3 to 4 degrees Celsius of warming rather than 2 on current policy settings. but we're going to get into trouble long before we get to 2 degrees Celsius.
Yeah.
And the emissions cuts that are actually required to get us down under 2 degrees Celsius are much larger than anyone in the policy community internationally are beginning to discuss. I brought the paper up in a recent post of mine. I made a submission to the government. New Zealand government is asking for feedback on its decision to kind of formally target a 50% reduction in in New Zealand's carbon emissions by 2050. They call it their 50 by 50 target.
Yeah.
And the Anderson and Bose paper actually kind of double underlines why a 50 in 50 target is grossly inadequate. Internationally, we need to be heading for, as I said when I discussed heading for 350, we have to be looking at getting rid of our carbon emissions, heading for a zero emissions, and heading below zero emissions. I mean, to get back into safe territory where the permafrost isn't going to melt, we're going to have to get down to perhaps the 350 level, maybe even lower. And that has enormous implications for how our economies are going to be structured in 50 years' time. And whilst perhaps it doesn't seem terribly urgent at the moment, we've put in place the kind of inertia of our energy systems and the emissions that we're making make it incredibly difficult for us to do anything to try and stop it at the moment. And that's before you start talking about people who argue, skeptics arguing that we should do nothing, or farmers saying they don't want to pay a fart tax or anything like that. If we get into the politics of it, the science is beginning to get really bloody depressing.
Yeah, and there's more discussion of this up at hot-topic.co.nz. There's a post there by Brian Walker titled "The Road to Ruin" as well.
It's a great post by Brian. I highly recommend a read of that.
Yeah. And that brings us on to our final story about the increased flood risk linked to global warming. In fact, we're going to talk more on this with our guest today as well.
Yeah, I just wanted to introduce the subject here because we're going to talk to Kevin about it. A couple of papers in Nature just released after the last show, basically finding that there is evidence for an increase in precipitation around the northern hemisphere, and that when you look at how climate models have been projecting that, they can say that one of the authors, Gabrielle Hegel, who's a climate researcher at the University of Edinburgh, says we can now say with some confidence that the increased rainfall intensity in the latter half of the 20th century cannot be explained by our estimates of internal climate variability. In other words, what that's saying is, she's saying, okay, we did it. It's our fault.
Yeah, with
some certainty. So it's hedged around with careful and proper scientific caution, but the fingerprint, the human fingerprint, the fingerprint of our carbon emissions can now be discerned in extreme precipitation. And the second study looked at a particular event, which was some extraordinary floods in Britain in 2000, and this was actually done by a group at the University of Oxford who kind of crowdsource their climate modelling, and you can go and join this this climate modelling process. The sorts of distributing processing model, Glenn, where people donate. There's like you run a screensaver, and it sort of works in the background and does valuable work.
Does all the calculations. They've done it for search for extraterrestrial life, that sort of thing.
Yeah, they did it for protein folding. Yeah. And this group at the University of Oxford does it for climate science, and they've run a number of different kind of experiments using this. But they use this sort of network of distributed processing on people's PCs to run thousands of iterations of a climate model to look at this flooding event, and they found it pretty much 90% likely that these floods were affected by the climate change that was going on. And that has policy implications. It means that we can, it means we can become more certain that we will need to plan for more of these events in the future. So what was perhaps a once in 100-year event becomes a once in 50-year event. maybe the once in 200-year event becomes a one in. Yeah, so the scale of things that you need to plan for in the future become larger. So they affect your planning decisions, your building decisions, and so on.
I can feel my insurance premiums rising as we speak.
Yeah, well, absolutely, and it's one reason why insurance companies are extremely interested in this work. Yeah. The Nature piece that news item talks about insurance companies looking at the change in risk of extreme events, because it affects the premiums they're going to need to charge. They can expect more damage coming in future, and they're pretty cautious people. They have to make sure that they've got the money to cover these events. So yeah. Interesting stuff.
All right, and we're going to continue some of this conversation with Kevin Trenberth, who's our next guest, Dr. Kevin Trenberth, head of the Climate Analysis section at the National Centre for Atmospheric Research. But first, I do want to mention that our new website is fully up and running, and it's good to see some conversation going on there. It's theclimateshow.com. Feel free to comment on this show or previous shows, also up at hot-topic.co.nz. And if you're watching this in video, you can take us around in audio format as well, and you can find that in the show note links, but also on iTunes as well, the iTunes store there. And there is also an RSS link in the show notes as well, which you can use to then put into perhaps Zune or whatever other podcast capture device you have as well. And of course, don't forget to just join in the conversation, whether that be on Facebook, perhaps facebook.com/The Climate Show or twitter.com/The Climate Show.
Absolutely, and Glenn's going to do another audio boo for you all as well.
I think we're going to do this one together, actually.
We could. Yeah, we'll do it together.
Straight after the recording of the actual show, we're going to, which will make sense after. Anyway, it's a time warp. But regardless, look out for audio boos that we will also be releasing on Twitter and up at theclimateshow.com. So our next guest is Dr. Kevin E. Trenberth. He's the head of the Climate Analysis section at the National Centre for Atmospheric Research in Boulder, Colorado. He's born in New Zealand, and he's also worked at the Met Service. Now he's based in Colorado, one of the highest profile climate scientists in the world and a regular subject of attacks by denialists. And he's not going to get a free ride here on the show either, I don't think. He was also unfortunate enough to be caught in the Christchurch earthquake as well. Come on in, Kevin. How are you?
I'm fine today, thanks.
Yeah, I put your description of the quake up on Hot Topic last week, Kevin. It sounds like it was an amazing experience.
It was not an experience I would recommend going through. It was. I still have a feeling of being somewhat stunned and a sense of disbelief about it all. And of course, it still goes on. There are aftershocks, and there are many people without power and water, even as we speak.
Yes, it's that feeling of numbness is something I think anybody in Canterbury can share. Even it was bad enough for us. We're about 50, 60k away to run out of the house, but we didn't feel anything like or see the destruction that happened in Christchurch.
Well,
but
yes,
you were sorry.
The building I was in is basically destroyed all around me. Fortunately, I was in a spot where I was under the table in the dining room, but the kitchen was destroyed. All of the windows fell in all around, and all of the cladding, all of the brick cladding on all of the back of the house fell off, and the house is not livable anymore.
So your family coping? Have they been able to find somewhere to stay? And
yes, so they've moved in with my sister's son on the in the Maryvale region, more on the north side of town.
Right, yeah, that's the part of Christchurch where my daughter lives. So, I was saying to Glenn earlier that the car park at the Maryvale Mall has been remodeled, so it's now got lumps where it used to be flat, but basically it's survived. So, anyway, from one kind of extreme to another, really, from Earth Science's on the ground to earth sciences in the air. I wanted to talk to you about climate extremes. This is something that you've made a number of comments on over the last year, in particular about the role of water vapor in making the weather we experience more severe. And there have been a couple of interesting papers in Nature recently looking at how incidences of flooding can begin to be ascribed to the climate change we're experiencing. So I just wondered if you could give us your thoughts on in that just sort of general area.
Yeah, so the attribution question is a tricky one, because firstly you have to observe that something has happened, and then you have to somehow say that it's due to a particular cause. And to do that, we require the use of climate models. Climate models are far from perfect. They're useful tools, and they've been used in this case to generate a result that suggests indeed that there are a lot of extremes of precipitation in particular that are associated with the human influence on climate. And the main part that is robust, and I think why they're able to get that in spite of the flaws in the model, is because what we call a thermodynamic effect, an effect that's directly related to the temperature, which is related to the water holding capacity of the atmosphere. As the atmosphere warms up, it can hold more water vapor. And this is very fundamental to weather and why we even have rain. As air rises and cools, it can no longer hold as much moisture, and so it rains. So it's a very fundamental process. But as the globe is warming up, it holds more water vapor. That gets involved in all of the storms. It rains harder as a consequence of that. And now we have an attribution study which says that indeed the human influence is playing a role.
I understand, I mean, I've heard meteorologists describe water vapor as the fuel for storms. So you get more, it's like throwing petrol on a fire in this case.
Yeah, the extreme example of that is tropical storms and hurricanes, where it's entirely fueled by the water vapor and the release of the heat that went into evaporating the moisture in the first place. And that's entirely the fuel from the storms, whereas extratropical cyclones also feed upon temperature gradients, the contrast in temperatures between the equator and the pole, and water vapor provides a powerful feedback, an extra boost to the rise of the air, and of course one of the consequences is the precipitation that comes out of it.
So we've just come out of a warm year globally. So would it be fair to say that if you overlay a warm year on top of a general increase, this helps to drive the sort of extreme events that we've seen in Queensland at the beginning of the year, and then there were some quite dramatic floods elsewhere in the world last year? Yeah,
so last year we had an El Nino up until about May of last year, and the heat from the tropical Pacific Ocean that has been stored up over the previous few years then comes out of the ocean as the ocean cools off, and it gives an extra boost to the global warming, which is caused by the increases in the greenhouse gases, the carbon dioxide in the atmosphere. And so when the natural variability associated with the El Nino and the human-induced climate change come together, then we really start to break records. And the records that were most stunning, of course, were the ones that immediately occurred after that in July, with record-breaking flooding in India and China, and then in August in Pakistan. And even by September, there was record-breaking rains in Australia, and the very high sea temperatures around Australia led to the extra water vapor that fed the flooding that has occurred in December and January in Queensland in particular. And so there's a US component to that, but there's also a global warming component to it.
Yeah. Now, the US didn't escape either, because there were some remarkable floods in Tennessee last year.
Oh, yes. That was last May, yes. And also extensive flooding in New England earlier in the year, and big snowstorms. So big snowstorms, there's sometimes people think snowstorms are related to cold. In fact, all snowstorms mean is the temperature is about freezing or a little below freezing. And if it gets too cold, there's a saying, you know, it's too cold to snow, and you get very light, fluffy snow, but it doesn't amount to very much, and you can blow it away. It's very dry snow. It's only when the temperatures are close to freezing that you get very heavy snows, and that's what's happened on the East Coast. They've given names to it, things like Snowmageddon in Washington, D.C. area. And so one of the consequences of one form of the precipitation, the snow, is that you can get heavier snows. And certainly in a continental environment, there's always plenty of cold air to make the temperatures below freezing.
So as terrible as some of these events are, is this also now helpful, though, for climate scientists, because we're able to actually see in the real world this direct relationship between climate and weather?
Well, this is actually what we're seeing, but explaining that to the general public and getting it across is another matter. There's, you know, natural variability. The weather varies over, you know, it never repeats exactly. There's an infinite variability that can occur. And so explaining the role of these relatively modest, at this point, changes that are due to humans and the increase in water vapor in the atmosphere that then feeds these storms and gives rise to these record-breaking rainfall and snowfall events, it's hard to get that across. And so there's an education process that's involved.
Yeah, we've talked on the show about a number of analogies. John Cook at Skeptical Science, his favorite is that what we're doing with climate change is training the boxer, and so that he can land heavier punches, and so the extreme weather that we get are the punches. You've also, I think, it said something like, and you can correct me, but there is a global component, a global warming component in every weather event, and it's only a question of how much.
Yeah, so the part that is most robust is the part that's associated with temperature. So the temperature has clearly gone up. It's gone up by over 0.5 degrees Celsius on a global basis. And along with that, there is about 4% more water vapor in the atmosphere over the oceans, where there's plenty of moisture. Over deserts, of course, the water vapor has not increased. Generally, over land, it's about a 2 to 3% increase. And so all of the weather systems that develop now are developing in the system, in the climate system, where there's more water vapor lurking around. And that certainly applies in the case of New Zealand. It's a maritime environment. There's plenty of moisture around. All of the storms that come in here have somewhat more moisture in it. It invigorates the storm. It makes the storm a little bit more intense than it otherwise would be. But in particular, you end up getting heavier rains as a consequence.
Yeah. So your sense of where we're heading here, you think that we are now living in a world where these sorts of precipitation extremes are going to become more common, presumably?
Well, we perhaps should also mention the other side of the coin. In places where it's not raining, there is an increase in energy that's available. That energy goes somewhere. It goes into evaporating moisture. As long as there's moisture around, it acts as an air conditioner of the planet, because the heat goes into evaporating the moisture rather than raising temperature. And so in places where it's dry, droughts are also exacerbated. And so in different parts of the world, you actually have floods and droughts at the same time, but in different places. And those places can switch. And so, you know, prior to last year, Australia was in record dryness. And Australia is a real case in point that is showing the manifestations of some of this climate change in ways that are very much adverse to societal interests.
Yes, I think the Australians, the poet who wrote that it was a land of drought and flooding rain, pretty much got it right. You mentioned earlier that there was with the heavy winter snows that have been happening in the Northern Hemisphere in the last few years, that there's been a temptation by denialists to jump on this to say that global warming wasn't happening. And you recently made a presentation to the American Meteorological Society where you talked about dealing with these sorts of messages. I wondered if you could perhaps discuss that with us briefly.
Well, that presentation, I talked about what is called ClimateGate. I was very much involved in aspects of that. 100 of those emails I was involved in some form or the other, and one of my emails went viral, and I don't know, at one point there was over 100,000 stories related to it, very much misinterpreting what was actually said. Well, I won't go into the details on that, but I was trying to draw some lessons learned from my standpoint, both in terms of what scientists should be doing, what the media should be doing, the role of the so-called denialists, and how we should try to interact with them. You know, if they're really denialists, then it's not possible to engage with them. But there are many people who have questions that we do have to engage in, and often the way in which we engage with them is through the media. The media are very much involved in news, and so climate change often isn't news. It's the same story time after time until we get a particular event that comes along. And so these are potentially teachable moments that we need to capitalize on if we can, but it also requires a good information base and sound science to back it up.
Do you find, as a communicator of these issues to news and media, that you're having to refine and distill what are complex subjects into something that is bite-sized, that can be used on television and in very short-form interviews?
Certainly, bite-sized short is desirable, and as I've been trying to do here, make it into language which is reasonably interpreted by the man in the street. But climate change is actually quite a complex subject, and so sometimes it's very hard to do, and one runs the risk that you can oversimplify, and then your fellow scientists may criticize you for oversimplifying, for not getting the details right or something like that. And so it's a difficult line to walk, actually.
Yes, and in that presentation you talked about what you called turning the null hypothesis around, saying that the burden of proof now was not to demonstrate that climate change was happening, but if people really didn't want to do anything, they should prove that we didn't need to do anything. We had to prove that, that it's a slightly different and much more difficult task.
Yes, so in 2007, the Intergovernmental Panel on Climate Change made the statement that, which was agreed to by 113 governments unanimously, that global warming is unequivocal. It's unequivocally happening, and it's very likely caused by human activities. And so as a result, it means that the whole of the environment that all of these weather systems are occurring in has been changed somewhat. And so rather than continuing to try to do it one variable at a time, precipitation, water vapor, winds, storms, hurricanes, and so on, as to whether each one of these has changed in the context of the very large natural variability that these undergo, the basic physics tells us that all of these things are developing in a warmer world that has more water vapor in it. And so the null hypothesis should be turned around. We should say, yes, unless proven otherwise, there is a human influence on all of the weather systems that we now experience. Yeah. I think that's certainly the position I've adopted.
So how do you get that message through? I mean, it's in the US, it seems particularly hard given the new makeup of the government in the houses of Congress, the Senate, and so on, and also there's a powerfully coordinated campaign to try to ensure that nothing is done within the US.
There are certainly very strong vested interests who clearly do not want to have to respond to this. And I think even within the federal government, some of the basic observations are not as well funded as they ought to be. And I think some people actually don't want to know what's going on. They would rather have a somewhat murky view of things so that they can deny that climate change is happening and they really should be doing something about it. There are going to be some hearings, however. In fact, I believe there's going to be one next week that's been called by the Democrats related to climate change. And, these are very partisan environments, and the senators or the people in the House, if it's the House, are very much in control of that. And so it's hard to tell how that will come out. But, I'm hopeful that the science is strong, and I'm hopeful that maybe that will actually have some positive outcomes.
Yes, at some point it has to be undeniable. But I mean, the real question is, you can look around the planet at the moment, and you can look at the ice melting, and you can look at the rain falling, and the flooding, and the heat waves, and everything else. And you ask yourself, well, what is it going to take to make policymakers realize they actually need to get moving?
That's right. And what can you say? Floods in Queensland. What's the Australian government doing now? Are they saying that, the drought's over, and now we don't have to do anything? Or people forget very quickly, and often the context is not there. And one of the things I've been arguing for is that we actually need better observations and a better climate information system. We really ought to have more bulletins related to climate about what has happened and why and what that means for the future, much more than we do right now. And unfortunately, the power of the media and the expertise of the media is actually diminishing. And so we don't have scientific reporters as much as we used to have even 5 or 10 years ago now.
And this is a question that we have asked many of our guests before, and feel free not to answer it because one can come across perhaps alarmist. But do you think there is a potential event that could tip the balance and that could make people swing into action?
I don't know. We've seen things like Katrina in the United States. Maybe the flooding is a major wake-up call in Queensland, and there was a very powerful tropical storm that made landfall there as well. And if it had been, a little bit further north or a little bit further south, it would have plowed right into a major population center. Yeah. I don't know. To me, these things are obvious, but that's why I'm talking to you guys.
Yeah.
Just trying to get the message out, right?
Yeah.
Well, we think it's pretty clear too, and it mystifies me why other people don't sometimes.
Yeah.
But anyway, so you've just said that you would be very much in favour of much more rapid and up-to-date climate reporting. I mean, you've called for much more climate monitoring in terms of gathering data, which is where that whole climate gate, where's the missing heat gone? You were talking about actually monitoring the system so that we could work out the nuts and bolts, the nitty-gritty of the way the system works.
That's right.
What sort of things? I mean, I've just been reading Jim Hanson's book, Storms of My Grandchildren, and he makes a point about we don't know enough about aerosols. We could have flown a satellite 20 years ago that would have answered this question. I mean, where do you see the big holes in the data that we're gathering at the moment?
I'm at a meeting in New Zealand at the moment, which is dealing with trying to build observations of the upper atmosphere dealing for climate purposes. At the moment, all of the balloons that are flown on a daily basis are for weather purposes. And so when new instrumentation comes along, they just change it. And as a result, the record that we have is very fragmented. It's very hard to interpret. The same thing happens with regard to satellites. You have a satellite that lasts for 5 years, and then you put a new satellite up with a new instrument on it, and you're not quite sure how the measurements of the new instrument relate to the old one, unless there's a period of overlap. And so we need to do a lot better on that kind of thing, and simply constructing the climate record and paying more attention to climate aspects as opposed to these large variations we see on a daily basis associated with weather.
Well, you've been involved with the IPCC process, been a lead author in the last 3 assessments, I understand. How do you think that could be improved to help to get the message over?
Well, the problem with the IPCC is it only comes out about every 6 years, and it's a great assessment, but it's an assessment of the published literature. It is not actually an attempt to produce the best prediction as to what will happen in the future. It's not what I would do at this point. I think the IPCC maybe has a role, but I think it's outgrown that role, and we need to go into something which is much more frequent and current to provide decision makers with information, and we need to really face up to the problems that we're trying to address, namely to produce the best prediction as to what will happen in the future, to guide people rather than just producing, well, this would happen if we do this, and this would happen if we do that, and so the policymakers then should be deciding whether we want this or that to happen in the future, and it's sort of a guidance for general policy, but it's not particularly useful for somebody who's building a water system for the next 10 or 30 years or something like that. So those are the activities I think have to be increased, and some of what the IPCC does needs to be operationalized, would be my view.
It's certainly one of the things that's concerned me with the talk about rebuilding Christchurch. I mean, if we rebuild a city for the next 150 years, we have to look at what is likely to happen over the 150 years, and that will include substantial sea level rise and changes in climate, and we need to be thinking about that now.
Yes, that's right. You need to. People tend to look only a couple of years ahead. We find it all the time, and looking further ahead beyond the realm of a elected politician is something that is quite difficult for some people to do, but a number of scientists are certainly doing that. I need to wrap this up now.
Yes, that's fine. We can see that the meeting is assembling behind you. So many thanks for finding the time, Kevin. I hope the rest of your stay in New Zealand is a little bit more grounded than your earlier episode in Christchurch. We hope that your family are coping well and will continue to cope well. So many thanks for finding the time to talk to us today.
Thanks. It's good to think that terra firma actually is.
And thanks very much for sacrificing some of your lunch hour there at the conference. Do enjoy the rest of your stay there. Thanks very much, Kevin.
All right. Goodbye.
See ya.
Thanks, Kevin. Bye-bye.
Cool, let's move on to the next segment here in the Climate Show. It's called Debunking the Skeptic. We do it with John Cook. He's from Skeptical Science, joining us in Brisbane, Australia. G'day there, John.
G'day, Glenn. Hi, Gareth.
Hi, John. How are you doing?
Yeah, I'm good, thanks.
So we've got a few things we want to get through, and you're going to talk to us first about short URLs.
Yeah, thanks for the opportunity to talk about this. I just added this new feature on Skeptical Science because I was finding a lot of people were tweeting and linking to various pages on Skeptical Science, and I just found it easy for myself too. It's just hard to remember URLs and keep track of it. So what I created was just this little domain sks.to that people could just use to create a short URL. So for example, if somebody told you that global warming was caused by the sun, then you could just give them sks.to/sun. Just give them that URL, and that'll automatically direct them to the right URL.
Now, I know this might not directly relate to the actual topic of the URLs, but this is slightly geeky. But I've always actually wondered that process of actually getting that short URL and that relating to your site, but it also is used to tweet out links to your site. How does it actually work, and how do you get one?
Well, I got the idea actually. It was probably last year. I just saw that the Climate Institute, which is a Australian organisation, they were tweeting these links tci.to as their short URLs.
Yeah.
And so I just emailed them and said, how does that work? Exactly the same question you just asked.
Yeah.
And I think TO is a domain for Tonga is the actual, like Australia, we have .au and you guys have .nz domains.
Yep.
So .to is Tongan domains. So I found a place that lets you register domains with a .to extension, and I just contacted them and asked them, was it possible for me to have sks.to?
Yeah.
And yes, it was. So I registered it and then just created a little script on my site that just redirected any domain to the appropriate Skeptical Science page.
Okay, so a little bit of coding required. That's all I need to know, and that's where I stop. That's it.
I can help you. I can help you with that. It took a couple of minutes to code it. So
okay, all right,
yeah.
cool. Anyway,
if you guys want to have, if TCS.2 is available, maybe you can have a climate show.
Yeah, it's not now that it's gone out. It's not available at all. It's gone. Someone's done it for us. Okay, so those are out there on skepticalscience.com, and people can start using them.
Yeah, I blogged it, but then just this morning I thought, well, it's kind of ironic that if I was going to give you a link, I'd have to give you a long link. So I thought over the next few days between this interview and when this show airs, I might actually create a short URL for the list of short URLs. So when does the show air, do you reckon?
It should be out Thursday afternoon, Friday morning.
Okay, so I've got about 2 days. And the URL will be sks.2/URL.
Okay, cool. All right, good.
Good stuff.
Let's look at what you're debunking this week. We're clearing up the misconceptions around hide the decline. What is hide the decline?
Hide the decline it's kind of the slogan of ClimateGate. The most popular email that was bandied around in late 2009 when the ClimateGate story broke was an email from Phil Jones where he talked about Mike's trick and to do with temperature records, and he also talked about who was it? Phil Briffer or Briffer's
Keith Briffer.
Yeah, Keith Briffer hiding the decline. So he talked about this in the one email, and then over time, this is, I guess, through Chinese whispers or somehow, this has morphed into this phrase, Mike's trick to hide the decline, and a lot of misconceptions have come up about this email, mostly involving not really understanding the science or even reading the email. And I just thought I'd just clear up some of the worst and most common misconceptions about it today.
Okay, misconception number 1, John.
The most common one is that scientists were trying to hide the decline in global temperatures. And what Keith Briffer was doing was not this at all. The decline doesn't refer to global temperatures. It just refers to tree growths in tree rings and how fast they grow in just a small number of locations in northern latitudes, up in the northern hemisphere, close to the Arctic region.
Okay.
So it's not global temperature. It's just a handful of tree ring locations. And the graph I've got here shows that over the 20th century, tree ring growth matches temperature changes in temperature until around 1960. And in just these certain northern locations, the tree rings stopped growing. Like they started to decline in growth at the same time that global temperatures go up. So they call this the divergence problem, which was the fact that tree rings were diverging from temperature.
So that's sks.to/diverge for those.
Yes, that's right. That's a short URL which goes into detail about the divergence problem. And so, I've heard Sarah Palin say it. I've heard a number of skeptic bloggers say that skeptics are trying to hide the decline in global temperatures. And you know that if anyone says that, they're either ignorant of the science of what the decline is actually about, or they're misleading people about what it's about. So that's the number one misconception.
But in general life, we all like to hide the decline, don't we, John? Generally, we like to
hide the decline in our looks and or the incline in our weight.
That's right. Okay, what about number 2 and your second point here?
Okay, so number 2 is this confusing Mike's trick with the decline. So you'll often hear people use the phrase Mike's trick to hide the decline. And in fact, there's a Berkeley scientist, George Muller, who gave a lecture recently, it's available on YouTube, where he actually used this phrase, Mike's trick to hide the decline, and referred to it as Phil Jones' actual words, as if it was a direct quote. But when you look at the actual quote, the actual email from Phil Jones, it's clear that Mike's trick is nothing to do with high decline. They're two separate things. And what Mike's trick is just, it's not even, it's a trick in the sense that it's a trick of the trade or a technique. And what the technique is just plotting instrumental temperature along with temperature reconstructions over the past. So this graph here shows the blue line, which is past temperature reconstruction, and the red line is instrumental temperature. Just putting them on the same graph so we can put past temperature change in the context of what's happening currently.
Okay, cool. And Gareth?
Yeah, well, I was just going to say that, of course, the real secret behind hide the decline is that it's really, and you've said it, you're about to say this, aren't you, John, that it's not hidden at all.
That's right. That's the third misconception, that hide the decline is like climate scientists' dirty little secret that they don't want anyone to know about this decline, when it's actually been discussed openly in the peer-reviewed literature since 1995. And there's just a series of papers where they talk about the divergence problem, what could be causing it, and many papers suggesting lots of possible causes. And it's quite openly discussed in the IPCC reports, in the third assessment report and the fourth one. They discuss the divergence problem and talk about this, how in 1960 the tree rings started to diverge from the temperature record. So it's an openly discussed subject, and this email doesn't change the science at all.
And Gareth has the short URL.
Indeed, it's sks.to/decline.
That's what I was looking for.
That was my best BBC announcer voice.
Cool. So have we got that covered, do you think, John?
Yeah. I just wanted to do a fairly quick one this week, just looking at those three most common misconceptions.
Cool.
Well, thank you for that. It's been great to talk to you as usual. Have any ideas about what we'll do next time?
Well, if nothing, this idea kind of presented itself, but if nothing presents itself, maybe you could ask on your blog and see what people suggest, and then
Okay.
I'll pick the one which is the least amount of work for me.
All right, well, out there in podcast land, if you would like to nominate either at the climateshow.com site or at Hot Topic something that you'd like John to debunk in the next show, please just add a comment, and we'll forward it and we'll watch his hair fall out.
That's happening fast, and I'm trying to hide the decline in that as well.
And in the meantime, prevent the decline over at skepticalscience.com. And John, we'll see you next time.
Thanks again, John. Fantastic to have you on the show.
See you guys.
Also, thanks to our media partners as well, scoop.co.nz and Celsius, CELSIAS.co.nz, for helping distribute the show and coming on board and getting some more viewers and listeners to the Climate Show. We're into the final...
I just wanted to add that if there's anybody out there on other websites who want to embed the show and help to get it out to an audience, then we're very, very happy for you to do that.
Definitely.
And I know that that's been happening at a number of sites, so we'd like to thank them as well. But if you've got a blog site or a website and you think that you'd like your readers and viewers to see what we're up to, then by all means feel free to embed.
And that's why it's on YouTube as well. That's why it's not some kind of lockdown, closed kind of platform to release the video on. That's why it's on YouTube. That's why there is the embed there. So feel free to use it and take it away. In fact, I haven't even got round to doing the Creative Commons kind of stuff, but maybe, I don't know, we should perhaps investigate doing a Creative Commons share alike or whatever it's called. But I think it's just implied these days on the internet. You know, you put it out there, then people can do what they want with it. Right.
Yeah, I have a signature on one of my emails. I'm just desperately looking for it at the moment. Let's have a quick look if I can find it, because it's you may want to edit this. Anyway, look, here we go.
Yeah.
This is one of my email signatures. It says, any original statements contained herein I place in the public domain and may be reproduced, modified, quoted or misquoted, in or out of context, in whole or in part, for any purpose, even just for the hell of it, and without attribution or obligation to me, which is more or less how the internet works anyway.
Perfect. And actually, that makes me think, if you're a lunatic, mad skeptic out there, and you've actually you've actually held in on the show this long because of being at the end of the show here. Feel free to, I don't know, cut it up and change our words and make it look like we said something else. That might be quite fun too.
Yeah, absolutely. Let's have a skeptic mashup where Renaudin and Williams claim that warming has ended, the next ice age is coming, and that the polar bears are doing very, very well indeed. Anyway, look, we're going to go on to the solutions part of the show, aren't we, Glenn?
Yeah, we are. We're looking at something called a green machine that sucks carbon dioxide out of the air.
Yeah, absolutely. We talked earlier on when I was being depressing about carbon emissions that we would probably need to go to removing carbon from the air. Now, one of the things that's proposed for keeping fossil fuels in use is what they call carbon capture and storage. And so people have been beavering away trying to find systems for extracting carbon dioxide, in the case of carbon capture and storage, from the gases given off when coal and oil are combusted. But you can also, in principle, do this from the atmosphere. And a number of people have produced designs, sort of, if you like, mechanical trees that will suck carbon out of the air. And then you can basically store it underground or chemically transform it into other stuff and dump it and what have you. Now, one of the key chemicals involved in this is a thing called an amine, which captures CO2. It's an absorbent. CO2 passing over it gets kind of stuck onto the amine, and this substance can be used it works. CO2 will stick to it, and then to get the CO2 off, you have to heat it up, and the CO2 is given off. What this new technology developed at the Georgia Institute of Technology in Atlanta by a guy called Christopher Jones, he's developed a way of kind of embedding this amine material in and I'm going to struggle to say this, but in a material called hyperbranched aminosilica. Okay. And so basically the chemical is held on the surface of a porous kind of silicon thing that gas can pass through. So these solid amines on the silica can release the CO2 that they've captured at a lower temperature than the liquid ones do. And so what this means is it reduces the amount of energy required in the carbon capture and storage process. It also works at the sorts of concentrations of greenhouse gases that we actually have in the atmosphere at the moment. So what it does is it makes the kind of economic feasibility of carbon capture and storage a little bit more attractive. It's worth saying that we haven't got anything more than pilot plants operating on this sort of technology, and the idea that we can somehow magically roll carbon capture and storage out to cover all the world's coal plants is about as mythical as thinking that global warming stopped. But the technology is coming along.
Okay, so it's coming along, but we don't know how useful it's going to be eventually.
Yeah, this is a step forward. It means that we're a bit closer to getting a technology that will help us to extract CO2, not just from fossil fuel waste gases, but also directly from the atmosphere. And that's a good thing, because I'm pretty certain we're going to have to go there.
We will have to go there, and we will have to go, Gareth.
Yes, we will indeed. I've enjoyed this show. It's been good. Particularly enjoyed the interview with Kevin Trenberth, and it's always great to have John on the show. We'll be recording again in a couple of weeks, and I hope for everybody's sake that terra firma, as Kevin said, remains terra firma in throughout New Zealand and throughout the many parts of the world where people are watching and listening to the climate show. And
we always appreciate suggestions for the show, and I know a lot of people have actually put suggestions for future guests, and we are working through some of those lists into the future as well. So thanks very much for putting those through, either in the comments on hot-topic.co.nz or theclimateshow.co.nz or .com actually.
Yeah, it's .com, that's right. I can promise that we will have David Suzuki on the show in the future, because we have a tape of a talk with David in the can, so that will be appearing in a forthcoming show. And yeah, we've got a whole bunch of interesting people to talk to.
Yeah, see you on facebook.com/The Climate Show and twitter.com/The Climate Show, and don't forget to subscribe as well to the audio and check out the video as well. Gareth, have a very safe 2 weeks, and we'll see you next time.
Thank you, Glenn, and I hope you and yours are just as safe as I hope I am.
Indeed.
Cheers.
See you, mate.
What good is a drop in the ocean?